Hello, everyone. This is Keith Jackson, and welcome to Jack's Math Notebook. In this video, we're going to learn about compound inequalities, and they come in two varieties. One of those varieties would be or inequalities, meaning that just one of those inequalities has to be true. But today, we're going to talk about and inequalities in which both inequalities will have to be true. And we have three big examples to show you how we can work these problems out. And let's start with the first one, in which we have 3 less than x minus 5 less than 10. And how are we going to solve this inequality? Well, all we have to do is just find the variable. Let's look at that variable. And then what we're going to do, we're going to isolate that variable by doing the opposite of the number that is next to that variable. And in this case, it is a negative 5. And so all we're going to do, we're going to add 5 to all the numbers in this inequality. And so when we do that, we have, first of all, we could just take away this 5 because a negative 5 plus 5 would just give us 0. Okay, and so as you can see right here, we're not going to put that 0 there. We're just going to just leave it as is. But we have a 3 plus 5, which will give us 8, and a 10 plus 5, which will give us 15, which lets us know that x is between 8 and 15. And we're going to use open circles because we're dealing with a less than sign right here in both cases. And so here's what we have. So we have x is greater than 8 right here. So we're going to put that open circle above the 8 while at the same time x is less than 15 that we see right here. And so that lets us know that x is any number between 8 and 15. All right, so that's kind of like a neat example right there. Let's move on to the second example, in which we have n plus 8 is greater than or equal to 9, and for n is less than 20. And so in this case, it might be best if we just work each inequality separately. And so let's do that. So let's start with this one, in which we have n plus 8 is greater than or equal to 9. And all we're going to do is just isolate the variable n by subtracting 8 from both sides. And so when we do that, we will discover that 9 minus 8 will give us a 1. And that lets us know that n is greater than or equal to 1. All right. And so we can just put that right here. 1 is less than or equal to n, or we could just simply just keep it like n is greater than or equal to 1. And let's go on to the other inequality, in which in this case, in order to isolate n, we're going to have to divide both sides of this inequality by 4. And we will discover that since 20 divided by 4 is given, it will give us 5, we know that n will be less than 5. And so here's how it's going to look. N right here is greater than or equal to that 1, while at the same time, n is less than 5. So we can write it this way, since n could be 1, right? Because that's what that greater than or that's why in this case, is this is why 1 is less than or equal to n, because that lets us know that n could be 1, right? And then n in this case is less than 5. N cannot be 5. It can only be less than 5. That's why we have this open circle here. And that's why we have this shaded circle here to represent that n could be 1 or any number between 1 and 5. It could be anywhere in here. All right, so now that we have that one taken care of, let's look at the third big example, in which we have a negative 63 less than or equal to 9m, which is less than or equal to a negative 27. And so you see these less than or equal to signs letting you know that we're going to have shaded circles right here at the bottom. Let's go ahead and work this out. And so in this case, we don't have to work each inequality separately, right? It would be better if we can just isolate the variable m right away by dividing all sides of this inequality by 9 that you see right here. And so let's start right here. And the reason why we're dividing by 9, because we want to get the m all by itself that you see right there. And so let's start with that. So a 9 divided by 9 would give us 1m, or just m, while a negative 63 divided by 9 would give us a negative 7, and a negative 27 divided by 9 would give us a negative 3. And it's letting us know that m could be a negative 7, okay, or greater than negative 7, or m could be a negative 3, but also less than negative 3. And so we can see it right here. And because these signs include these numbers right here, this is why we have to shade it in. So m can be any number in between negative 7 and negative 3, while at the same time, it can also be negative 7 and negative 3. Okay, you have been given a lot of information. I wouldn't blame you if you need to pause the video to take a look at these three big examples or replay this video as many times you need to gain a deeper understanding of the concept of compound inequalities. But in the meantime, please comment, share, like, and subscribe to Jack's Math Notebook for more content. Thank you and goodbye.